Binomial expansion for 1 plus x to the n is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and then we just carry on that pattern. Here we can write this as 1 minus y to the minus 2. So this is our x as such, and this is our n. And therefore 1 over 1 minus y squared is equal to 1 plus minus 2 minus y plus minus 2 minus 3 over 2 factorial, which is just 2 minus y squared plus minus 2 minus 3 minus 4 over 3 factorial minus y cubed, which just has to go up to the term in y cubed. So this is going to become 1 plus 2y, because there's a double negative. This 2 is going to cancel out with this 2. The negatives are going to cancel. The minus y squared just gives y squared, so it's going to be plus 3y squared. The 3 factorial cancels with minus 2 times minus 3. There's a triple negative here. That will cancel with this negative, so it'll be plus 4y cubed. Actually, this comes up more often than you think in AEA papers. I think it's come up twice already in previous papers, so it's one to kind of become familiar with because you get this nice pattern 1, 2, 3, 4. In part B, it says hence or otherwise show that this is true. And the hence kind of means we can use part A to help us. We just need to get the left-hand side in the form 1 over 1 minus y all squared, and it doesn't look anywhere near that at the moment. So I'm going to have 1/4. I know that cosec is 1 over sine, so I can write it as sine squared theta over 2 all squared. Like I'm just sort of trying to get it in the right form. Now I need to change the sine squared theta over 2 into 1 minus y. And like the thing that's calling out really is double angle formulae, because if you have double angle formulae, then we can write down half angle formulae. So I've got a cos in my final answer, so I'm clearly going to replace this by 1 minus cos somehow. I'm going to write down, it's not going to be the double angle formula for sine. I'm going to write down the double angle formula for cos. So, sorry, not cos squared, but cos 2a is identical to cos squared a minus sine squared a. I don't really want cos squared in there as well. I've got a sine squared, so I can replace cos squared by 1 minus sine squared. It's going to be 1 minus 2 sine squared a overall. And this is really good because I can now replace a by b over 2. So cos of b would be identical to 1 minus 2 sine squared b over 2. I've just replaced a by b over 2. They're the same sort of thing. And that means that sine squared b over 2 Well, I can add it to both sides. I can minus the cos b. I can divide by 2. It's going to be a half minus a half cos b. And therefore, a quarter cosec to the 4 theta over 2 is actually equal to a quarter 1 over, and I can replace that sine squared theta over 2 by a half minus a half cos theta, which I then have to square. I want to do a little bit more. I can factorize out a half, so I get 1 minus cos theta, and I'm squaring the whole thing, which is equivalent to squaring this and squaring this separately. Now that is just a quarter, so if I'm dividing by a quarter and I'm timesing by a quarter, they just cancel out, and I've suddenly got a really nice result. And I can just expand it now, and it's basically, like you can see, it's just the equivalent of this, but with y replaced by cos theta. And I'm just going to write down exactly what they've written down here. So it's always, this bit is 1 more than the power. I'm just going to say using A. The key bit is getting to here. Okay, nice job. All right, 2 more parts to go. Now we have this series, and it would be worth just looking at the series that we have already. Remember, we have this thing here. And it's equal to this, because there's some similarities going on. Now, if I compare this with this, I can see for C that summation is, I'm going to call this star, like this bit here. It's the same as the star with y replaced by a half. It will equal 1 over 1 minus a half squared, which is 1 over a half squared. Now that is a quarter, so it's 1 over a quarter, and the answer is 4. D looks a little bit more complicated, but actually it's just alternating between positive and negative, and you can see that it's going to be y is equal to minus a half. That will work here, and then here, when you square minus a half, you'll get a positive. Here you get a negative. So it's going to be minus minus a half, which is 1 plus a half. That's going to be 3 over 2, which if we square it, gives us 9 over 4. So finally, we're going to get 4 over 9.